For us at Fortinet, it's always a pleasure to be here in one of our favorite events to show you and demonstrate you how we protect customers and actually what our customers' challenges and how we can help them. So today's session, we try to be not like presenting only products. We want to show you some real life scenarios in a red blue team approach. So I will try to be the bad guy, and Srija on my side will be the defense side and exactly protects everyone here in the room. But starting with that, one thing up front, our teammate Aiden Walden could be here today. So he's our Global Director of Public Cloud Architecture and Engineering at Fortinet for the past 6 years. And prior to Fortinet, he served in various engineering leadership roles as a Tier 1 mobility and global at Tier 1 mobility and ISPs. And throughout his 19 years of career, he has navigated through evolving security landscapes across mobility, IoT, and service provider infrastructure. Right to me, next to me, Srija, my teammate. Srija, may you introduce yourself, please?
Yeah. Thank you so much for having us here. I am Srija Allam, and I'm a cloud security engineer here at Fortinet. It's going to be 2 years for me at Fortinet, and I help our customers deploy all the security products in Azure and also in other clouds sometimes. And prior to Fortinet, I've been a network engineer in operations and with different companies. Julian?
Thank you, Srija. So some part of my team, I'm a bit exotic here. So I'm a global SAP security systems engineer. So I'm usually focused a lot around SAP security, which means at the end, I'm doing a lot of application security primarily. And besides that, I'm focusing on that part. I'm also focusing a lot around threat research and reasonable attack vectors. So I'm having a lot of touch with the bad guy side, and also on the blue team side to learn a bit how we can defend and make even systems and landscapes a bit more secure. For today, our agenda, what we want to present you is we start a bit with a small overview with an introduction around application security in the cloud. So our biggest focus here is about what we do from Fortinet side, what are the innovations and challenges from an application security perspective, and switching over to web application and API threats and how we can protect those attack vectors. So also moving more over into also cloud native security application, which is indeed a challenge in actual times. The second part, we move over into a demo where Srija and I will show you some active or attack defense part, where we first start off with some cloud native network security protection, then move over into integrated web application security. And after that, we will combine that in a full story, speaking about native application security awareness and how does all of that tackle together into CI/CD security lifecycle. And for sure, at the last part, and as usual, please feel free to ask anytime your questions, and happy to answer them. With that, let's move a bit in. And so the many security challenges that customers bring to Fortinet generally align with specific necessary outcomes. First, we talk about agility of application delivery, which must be optimized and cannot be inhibited by security of the lag therefore. This means security must be likewise agile. So we cannot be that static like maybe previous. Also think about talking about cloud in the DevOps. There's a continuous development, it's changing, and it gets redeployed, maybe multiple times in an hour even by that. So we need to be as flexible as possible to exactly come up with that. As a second part, the risk reduction is a really high part, and this has to be at the lowest cost possible. And also risk doesn't mean compliance. So there is a small difference. And bringing all that together and also optimizing the costs. So there's finally the cost optimization, which is important to the customers. So for sure, I mean, security often provides the feeling of we need to have additional tools, additional people, additional services, and additional knowledge, which has to be there. But it's exactly not the case. So the cost needs to be low, it needs to be optimized. That doesn't happen. And bringing all that together, Fortinet is providing a huge platform or a fabric, so what we call the Fortinet Security Fabric, which brings various sources, capabilities, and tools together. So we call it, so we bring convergence, platform, and the threat intelligence and security services together. Because if you have standalone products, it doesn't help you if you have always only silos. For everyone which has some or has already worked, for example, in the SAP world, you know, there are many silos. So we have those application guys, we have those developers. They often do not speak with others, and except especially not with other infrastructure people. And exactly this needs to bring together, and the information has to be exchanged to defend threats. And that's exactly what Fortinet is doing with the security fabric, to apply threat intelligence across, also integrated with an open ecosystem. We have there over 500 solutions in our fabric, which can exchange information over that from over 350 vendors. So when it comes to the cloud security, to an application journey, so that application has to be secure. And for that, a constant application of security must be available wherever the application exists, be it in the cloud, data center, edge, or even, for example, on a client. So we see that applications are the greatest concerns of those modern web services and the use of APIs at scale. So think about this. So we have the infrastructure, but moving a bit away from that in the future, talking about cloud native applications. No one cares anymore about the infrastructure. It's all about, we bring an application out there and there's some communication out there. How, what, and in detail. That's shifting a bit away. The focus is more on the application stack itself. And that's exactly the point in cloud native. And there needs to be some security. And that's exactly what we can provide here. So we have a hybrid security approach. We have this web application and API protection. We provide the cloud native protection. We have a workload protection to exactly bring your visibility into these insights. And even by that, we have our FortiGate services, which provides threat intelligence information with hundreds and thousands of sensors worldwide, checking what's going on there in the world and exactly what needs to be done to prevent those. Or threat intelligence, I mean, we're looking what are the bad guys are trying to do. Let's exactly do the opposite of that to keep them out of our networks. Coming or speaking about our FortiGate labs, there have some three key areas in our FortiGate labs. So FortiGate labs is our threat intelligence and research organization at Fortinet. And they're bringing one of the industry's most knowledgeable threat hunters, researchers, analysts, engineers, and data scientists together to exactly provide those informations to all of our customers out there, and also into our various organizations we work together, like the Cyber Threat Alliance, for example. These three key pillars are threat intelligence, to bring in with our thousands of sensors all these informations. In addition to that, for sure, we leverage AI tools to find out all these key identifiers and key identification information to know what happens and what's going on there. Exactly. So, and one of the challenges with agile application and cloud security is the multiple personas involved in workflows and multiple points at which security must be applied within that given functionality. I always mentioned those silo problematic when we talk about, for example, we have the development team, we have the application operations team, we have there an infrastructure team, a network team, and so on and so forth. For that, it's important to align the use cases and product features in a way that integrates into segmented work streams into a continuous security delivery model. So, and that's exactly where we at Fortinet focus on how to achieve the organizational alignment and application security by that and the delivery. So what we are doing, we're automating that workflow and between those teams, because removing the human factor, bringing in automation, brings in also more security. And that's exactly what we also want to demonstrate you in our session and our demos today. So speaking about an application lifecycle and how we can, or how it can be protected. So the application security in general falls into two primary focus areas: the shift left pre-production and the shift right, the production area. So the opportunity for pre-production is in how far into the margin we can reduce risk and shrink the attack surface. We can affect risk and improve our security baseline at the least cost there. So after the application gets into production, this is the point at which an application will face the highest risk. So for sure, in the development, we have our own secured environment. It's not out there. Not everyone has access to it. It's just our own great world. It's our tiny little pony world. So, but when it comes to production, that's the rough world. That's where everyone wants to do something with it, if it's intended or not. And that's exactly where also a lot of stuff can happen. And especially there, when it comes to production, that's the point where an application has the highest risk. And there, the security must adapt to the user inputs, behavior, identify malicious versus benign anomalies, and that without affecting anything of the usual benign behavior or making it even more complex to go out there. And that's exactly what we want to show you today. So for our demo workflow, we have prepared a pretty simple and very basic application, so to say. We want to first start with speaking about how we can help on a network security side. So how can we provide some segmentation, how we can achieve that, how is it able to, for example, do ingress-egress traffic controls, speaking about cloud-native application. In the second part, we move over web applications. How about that? How can we help? Speaking about cloud-native applications, they're somewhere thinking about, for example, AWS Lambda. How can you place their web application firewall and how does it help you within the development cycle? I mean, what means the developer has to be now a web application firewall administrator? Stay tuned. And as the last part, we show you exactly how we bring these points all together. How can we have that flow and how can we prevent vulnerable code to go into production? How can we keep that stuff away from our ugly, bad, maybe critical environments out there? And with all that, let me directly bring Srija back on stage and let's have a look in our demo environment. So again, Srija will be the good person here in our room. I will try to be the bad guy as good as possible. And for that, maybe some of you know already, the last time I tried to break into Srija's shoe shop, didn't went that well for me. So I was able to break in. I had a bot and stuff like that, but she always catched me. And this time I noticed Srija has a fantastic blog, the AWS Goat blog. And it's pretty cool. I mean, for sure, blog applications are always great because dynamic content, so there can be potential a lot of vulnerabilities out there. And that's what I did. I had a closer look at those applications. And for example, if we have a look at the source code, I hope it's big enough for you all. We can see there are some embedded AWS buckets. I mean, it's a simple, pretty well-known technique, right? If we go to that bucket, for sure, somewhere the data has to be stored. We can go there. We find that picture. That's nothing malicious or critical, for sure. But if we have a closer look, so what could happen? There could be a misconfigured S3 bucket, for example. But in that case, it's access denied. But maybe you will notice it's named with production at the beginning. I mean, someone had to develop it, right? So what about development? It doesn't exist. Okay, one last hint, devs are lazy. Who says nowadays development? It's too long. Dev. And look at that. Congratulations, we have access to an S3 bucket, which is not secured. Again, devs are usually maybe not lazy, but they have other things to take care of, to be honest. If I would be a developer, I don't care about permissions. It has to work at first. And I have a closer look. I see some index.html. And oh, look at that, an SSH config. That's pretty cool. And if we go a bit further, oh, cool, we have SSH keys. Seems like we found your developers' shares. Great. Cool, let's have a look at that. So if we go there in that config file here. So what do we have? We have a usual SSH config, but quickly looking onto that, only 2 public IP addresses. So everything else is not that interesting. And we notice we have the SSH key of our Vincent van Gogh. Fantastic. Let's keep that IP address in mind. Let's grab our SSH key. And then let's have a look what else is going on there. So let me copy that. For sure, I'm well prepared. So I also have a bad guy server here. Let me download that quickly. So make it for me usable. And then let's log in as the Vincent van Gogh. So Vincent van Gogh, and what was the IP address? This one here. And here we go. Fantastic, we are in. As an attacker, I mean, that wasn't that magic. So what we want to do here now quickly is I want to help Srija a bit, and I want to patch that server. Just be friendly. So let's quickly install a patch. It's a Linux update, nothing fancy, but what she doesn't know, we have access now with our C2 framework. We have a backdoor installed. So I don't care about SSH anymore. I'm good. Let's move out of that. And if we can see down there here, the agreed contract beacon joined my C2 framework. We have a look at the beacons. Communication is active. Perfect. We can interact with that guy. Start an interactive session. Wait until it happens. And yeah, Srija, I think it's fine if you say thanks that we patched your machine.
For sure.
So tell me,
Yeah.
what do you want to do? I mean, we breached your box, right? We are on your network.
Sounds good. So it seems like you have developed your skills and you worked on it for sure. And meanwhile, I was also working on my end to see what we can do better. So can I share my screen?
Yeah, sure.
So Julian tried to obviously get into the EC2 instance here. We just saw that. So while Julian was again working on his skills, we released a product at Fortinet called FortiGate Cloud Native Firewall. It's a software as a service product, which helps with the cloud security, and it also provides like availability and like scalability. And this one is actually, since it's a software as a service and is cloud native, the security teams do not need to worry about like configuring, implementing, or making changes to any of the firewall software, right? Like if we want to deploy something in cloud, but this is a software as a service. So what they can do is mainly concentrate on the security policies or security profiles here. So let me do something, Julian, first, and then I'm gonna show everyone how cool the FortiGate CNF looks like. I was just allowing you to show again your skills one more time. So just applying that policy there. I have prepared a pre-policy already with some security, profile groups in order to prevent that kind of attacks. So I just applied that, and let's see here. So it's applied. It's called AWS Goat Policy Set. This is a CNF instance running in AWS. It's an EC2 instance, so we have our CNF instance that is trying to pass the traffic, everything through FortiGate, here, again, FortiGate CNF. And here are the policy sets. So the policy set is nothing but group of collection of policies in an ordered set. So it can, so that organizations or security engineers can focus on creating policies and applying to their instances in cloud. So I am only allowing my friends from Germany to get access to my web server. And then I'm also telling my web server to go outside or outbound to anything in the internet. That's what my policy set is. And again, it's a collection of policies, a group of policies. We can have more than 2 here. The other thing is the security profile groups. Security profile groups are like pre-configured, like a few of the IDS protection here, intrusion detection profiles. And what we have is the DNS filter and known bad IP blocking here. And we can entirely customize this as well. So also we see there is some redirect botnet for CNC kind of attacks here, which are enabled. But if I click customize, one thing I have done is I turned on FortiGuard category-based filters. These are provided from FortiGuard service by Fortinet, which is a threat detection team at Fortinet. So we already have all of these categories here, right, with the bad or category-based filters. But what I've also done is, I know Julian is definitely a renowned hacker, good name, actually bad name. So I took his domain, and I have already told that I just want to block his entire domain and redirect to a block portal if there is anything going to that domain, if any traffic is going. So I've done that, took that domain, set it as wildcard. I can actually double click this and set redirect, and the status is enabled right now. That's what my profile group consists of, a collection of IDs, and this is reusable. So say if you have a different instance or AWS account and you want to protect these different instances, you can apply this profile group as well. All right, Julian. So this is again our FortiGate CNF. It's a nice dashboard. Software as a service can be subscribed from AWS Marketplace. And yep, do you want to show what you can do now again?
Yeah, I can. And I literally can do nothing anymore. As you exactly, what were my thoughts? You can see my beacon was last seen over a minute ago. It was seen, so it's gone. And that's exactly one point, what we want to target with FortiGate CNF. So ingress protection is definitely helpful. And if you have a port filter, it helps. But what we can do here is various things. So we have ingress and egress protection, and egress also we can check for to whom we are communicating to. Because going in, I mean, legitimate access would be SSH. There is nothing wrong at the first point. Maybe I have the wrong location at that kind because I'm sitting in the US, not in Germany, 1 or 2 miles away from there. But usually I'm using a legitimate protocol in a legitimate way. But what I want to try to do is using my malicious domain to send some malicious traffic. And that's exactly where we can help with FortiGate CNF. So what we do with FortiGate CNF, we bring the firewall security solutions on an easy way out there, which can be leveraged by customers. So we bring that enterprise-grade network protection, which with our threat intelligence service from FortiGuard, what Srija showed you, together with the simplified operations. So you have seen how easy it is to set it up. To be honest, it's within 2 or 3 minutes, you're in there. You have it set up on your AWS environment. And that was simple management. So, and the reason why we want to keep it simple is, if we think about the development or DevOps people, they're not that only firewall concentrated. It should be that simple that everyone can use it and configure it without having a huge knowledge with the network environment and security environments. It should be simple to provide there. And the cool thing is with CNF, you don't need to take care of, are these instances high available? Are they big enough to handle my throughput? How does it work? Does it intercept my traffic? And everything of that. No, you just send your traffic to an endpoint within AWS on a VPC endpoint. We send it over via gateway load balancer. So using the cloud native capabilities, we take care of running those instances at Fortinet. For you, we scale them up or down. At the end, for you, it's just, I have there some environment which I can control and have my controls over. Yes.
Apologies if you already answered this. Is this just AWS?
Right now, it's just AWS. Yeah.
Got it.
That was
Okay.
my next question.
Right now, yes. What we do is outbound traffic inspection, inbound traffic inspection. For sure, we can also do east-west traffic inspection. So one important thing is what we leverage there is we use dynamic objects. So we don't care about certain specific IP addresses. You can use them if you want. But what we primarily focus on is we leverage, for example, tagged objects. So if you redeploy your object, just give it the same tag. Your policies apply automatically. So we have the dynamic integration into that cloud environment. In addition to that, we have our FortiGate CNF console, which Srija showed you. But in addition to that, for example, if you already were running somewhere else, other FortiGate firewalls, and you manage them centrally in FortiManager, you can also plug that in. You have your usual look and feel like you would have with the other firewalls. But in that case, you just also administrate the cloud native integration. Or just another alternative, if you're already familiar with AWS Firewall Manager, for sure, we also integrate there. Feel free, use it, and have the same look and feel there also too. And some key differentiators is that we have the security aggregation. So you can also plug in multiple VPCs, which are separated, should not be communicating with each other, but you want to apply security policies on one instance. Even that is possible within one region. Or using the dynamic policies, having a single pane of glass management. So with, for example, FortiManager, even if it's on-prem or cloud, it's the same. You have one view. And for sure, the predictable costs. And bringing all that together, you have a next-gen firewall, you have the advanced security. To be honest, from a feeling there, it's pretty easy to use. It's pretty simple. So you don't have the huge overhead for operations. And for sure, you have optimized your TCO. With all about that, that's just network, that's just segmentation. We're just filtering some ports. And to be honest, that blog page can do by far more. And I had a closer look at that. And let me come back to that a bit, because on that blog page, we just scratched on that surface, right? So, and we as noticed there on the top right corner, there's a login field. And as we already know, we are running somehow on AWS. Could be possible it's a Lambda. And Lambda has some pretty cool capabilities also from a bad guy perspective. And what I already did is I created myself a user.
While you're doing that, you mentioned about the ability to sort of have the dynamic objects or the tagging of things, so you don't have to specify specific IP addresses. Can you have a rule that will kind of block all untagged objects by default? If someone forgets to tag something and therefore could have a policy missing?
In the FortiGate CNF, so right now we have to tag the instances with a key value pair. So that's how it's going to detect the instances on the FortiGate CNF console. I mean, that's to add a CNF instance, I meant. So it's the key value pair that is required there. So you tag an instance on AWS and that shows up. So we didn't show the process of creating a CNF instance initially, but the first step when we add is to select what instance you want, and it will show up when it is actually, when you're tagging the instance on AWS. Does that help?
Yeah, that does.
Okay.
Thanks.
So in the meantime, I was able to log in as my user one. And looking around at that application, we see there's a capability to send up blog posts. Cool. We are able to block our stuff here. And what is quite interesting is we can enter an URL for an image. That rings a bit of my alarm bells, because that's usually potentially an SSRF vulnerability. And we can test it pretty simple by going there and try to dump our passwd file, right? So if we click on upload, we can see our picture got uploaded, but we see nothing. So in the background, I have some man-in-the-middle proxy open, and we can see on the top, there's the save content request. And if we click on that, we can see on the left here that value file etc passwd was requested. And here on the right, I can see a picture returned back. So if we have a look at a picture URL, it's a bit tricky, but if we look at that, we get an access denied here. Why we get that? Because I forgot to copy the G. And we get a picture. I mean, we know that picture will not really work, because that's not really a picture file. But if we would open that, it does get catched by the proxy. It doesn't get. Anyhow. So if we look at that, let me download it quickly. So download that file. And if we cut that, so if we have a look into that content, we can see that looks pretty well like if we would have dumped the etc passwd file. So somehow that picture got a bit malformed, but we can access your information, right?
Mm-hmm.
And what is the interesting part now with that? As it's a Lambda function, we can say to Lambda, hey, please jump one step ahead. So we manipulate the Lambda runtime jump on ahead and to do like if you would attach or do post that stuff into your database. What happens to that is, just thinking out loud here, that our Lambda function will get the authorization within AWS to do something on a database. So, and if we then dump our environment variables, we could maybe grab out those session tokens. That's a pretty easy one to do. We just need to send another request. But you see, it's a bit more complex than I would say just finding some SSH credentials there. Let me just hop over and replay that attack and send the request with the Lambda runtime manipulation there. Just send it. And we get a picture back, which is actually good. And as a second step, what we now want to do is, as we got that picture, let's dump our proc environment files. So let's dump that. Get again that picture. So let me download that here, make it right bigger. So if we have a look at those, where's it downloaded?
You're missing a G.
Again, yeah.
A J?
Oh, P.
Oh,
Then
oh.
yeah, you're
I have a problem with that G. I don't know why. And it should be which one? The 7.9, that one. Maybe some of you guys which are playing a lot with AWS maybe see something familiar. We see some session tokens. We see some secrets. We see all the interesting information which we could now use there. Let me copy that quickly. Drop it into some text editor and have a quick look. So what do we have? We have that one, which is until here. Zoom is there. So we have the AWS session token. Then what else do we have? We need an AWS secret and a secret access key, which is right there.
So you could see it's a Lambda function. That's where my serverless application, and you have access to the secret key, the access ID, all of that information, right?
Exactly. So what do you think I can do with that?
I'm sure you're going to show us, Julian.
I hope so. So if we export those information, and if I did not miss anything, we can impersonate to be that Lambda function. So switching back to my attacker machine here on that screen, just setting it as some environment variables. And fingers crossed, it looks cool as it should. I can try to look at my permissions. And voila, it worked. So what I did now is I impersonated to be that Lambda function. And if we have a closer look, I can see that's my user. I'm right now in AWS within Srija's environment. And I see there are two Lambda functions. One is based on Python, one is on Node. And congratulations, I have access to your database. So it seems like a new data breach is incoming, right?
Yep.
Cool. It's nowadays a bit normal, but
Yeah.
how you want to now prevent that? I mean, your network firewall, it's not really helpful at that point, right?
Right. So we have seen a lot like this previously, right? Big companies have all of our information, personally identifiable data outside in the internet. And we all know about those breaches. So just one of a kind here. Share my screen.
Let me stop sharing for you. Please hand over.
So if you have watched us previously at Cloud Field Day and Tech Field Day presentations, we used Juice Shop. So Julian tried to order a lot of juice from my Juice Shop. It's an OWASP application. It's an application from OWASP project. This time we have done AWS Goat here. So I know Julian have took so much time to do all of this attack. Obviously, he spent a lot of time here, but I wanted to show how easy it is to protect this kind of attacks with our FortiWeb, which is a web application firewall and is a SaaS offering as well. So FortiWeb Cloud can be subscribed from any of the major clouds like AWS, Azure, GCP, and OCI. So all you have to do is subscribe onto the AWS marketplace. I'm just gonna show that here really quick. And once we subscribe, it's more about like creating a social media profile. Since I've already subscribed, it's obviously showing this one, but once we subscribe, create a social media profile kind of thing. So you will create a support account on support.fortinet.com, and then you will be logging in on FortiWeb Cloud here. So even before, I wanted to show what actually I want to show. I want to show again how easy it is to onboard the app. All right, right at the time, it just logged me out. I'm going to log back in again.
So you will put your web application file in front of the serverless application on AWS, right?
Correct.
Without fearing any interruption there.
Exactly.
Okay.
Yep. So yeah, so my application is running. I want to show how we onboard an app and how FortiWeb can protect from these kind of attacks. So if you see in the list here previously, there was not AWS Goat. That's the one which Julian tried to attack. And what I'm going to show is I'm just going to click a different application. So it's called app. I'm just going to give a domain name. This is the domain name what is exposed to the internet. This is where all the traffic is coming. So I just picked another application, not AWS Goat yet. This is to show how just 5 steps we can onboard this application on FortiWeb Cloud. So it just sees that that FQDN is resolvable to an IP address here. Let me copy this. And then this application is reachable or is on port 8443. It's listening on 8443. So I'm just going to test it. This is a required step in order to say FortiWeb is able to reach this app and then send the request if in case any user requests, right? Because it starts intercepting the traffic before it gets to your application server. When I say application server, it could be serverless or server-based, running in your on-premises or any of the public cloud platforms. So I got my test successful. Let me click next. We also offer an option for CDN. You can enable CDN here, and you see in Americas, there are a few scrubbing centers here. And the reason it's showing few of this is because it identified this application I have is running on Microsoft Azure. So based on the IP, it found out the origin and the cloud. And then it's saying it's in Americas, it's running in US East. So that's what it's showing here. And it's also showing us the scrubbing centers. So what happens is if there is a user who's trying to request your application from US West, it doesn't need to come all the way to US East. But since our scrubbing centers are located in US, and the requests will be cached in the scrubbing centers, and the request will go to the nearest scrubbing center. So there is no latency for this kind of request. And there is also global. And if the application is on AWS, the scrubbing centers are different from Azure and also goes with the different clouds as well. And say your application is on premises, we still have like default scrubbing center, one for US and one for the rest of the world in Europe. So that's what it will be, the FortiWeb will pick. So I'm gonna just turn it off for now and then click next. And this is the place where we select if you want to enable block mode or not. So what it is giving us is if you turn off block mode, it's called monitor mode. Here in the monitor mode, it will just allow the traffic to your application server, but it's not going to block any requests. But the use of this is that you can see in the attack logs what kind of attacks are being targeted at your application. So as a security administrator, you know how many bots are coming, what kind of attackers like Julian are trying to hit your application, and then basically create security policies so that you would avoid false positives based on our configuration, right? Or else if you want to start FortiWeb to block those kind of attacks, we enable or turn on block mode. And there is also a template here, which we can turn on. Template is collection of security policies. And say if you have an application of Drupal, which is like 5 applications of the same type, and you want to apply a central template, you can do that. But what we have seen is most of the organizations are now moving to CI/CD or DevOps kind of approach. So, and if you want to introduce that and have an application use like again the automation approach, you can do that as well, because FortiWeb has a complete API. You can control it through API. That's going to be my next demo of onboarding the application. But that's an option here. And we click save. That's the last step. Here, in the 5th step, what we have to do for FortiWeb to start intercepting the traffic is to create a CNAME record. So right now, my application has an A record in my Google domain registrar pointing to this IP. All I have to go is change it to CNAME and then update it to this CNAME, which is generated by FortiWeb, so that it will start intercepting the traffic. It will check all this traffic based on the security policies, and only legit traffic would be allowed. If not, it will be blocked. Now, coming back to the approach, right? Like I said, I like automation here because our organization is completely, they want to do automation. And of course, being a developer, the lazy developer Julian was telling about earlier, that's me. And I want to basically do, because I release and I create a lot of microservices in a week, right? And we just want them to be protected as soon as they're released, even they are in the development or in the production. So we just want to onboard that here immediately as we create. What I've done is we use like Jenkins. I've used Jenkins here, and I have this pipeline already built. If you want to see the pipeline configuration here, it's actually running an Ansible playbook. I'm just using Ansible as my config management tool. And Ansible is, this is a FortiWeb cloud.yaml file, which will onboard our application. What it's going to do is, which is the AWS GOAT, and it will create a CNAME record on my domain register. For this time, I'm using AWS, so it's just Route 53. That's my domain register right now. So it will take that CNAME, it will update that CNAME, and also turn on all the security profiles needed so that Julian won't be able to do that attack again. So let's run this one. Not going to save. Just going to click build now. So it's running. Few of the steps here. So it's updating CNAME records, like I mentioned. So in the first step of the Ansible task here, it have actually created that app. It's called awsgoat.cloudteamapp.com. And then there is a DNS record here that was generated. And it's still updating. The Ansible is updating on the Route 53. Julian, do you think you're going to win this time?
I hope. If not, I'm not sure if I will keep my job.
So it updated that Route 53 record for us. And it's also turning on few of those security profiles, like I mentioned. And we'll go there once this is a success. So it seems like it's running all of this. Let me get down to the bottom of this job. So it finished its success, right? It's done. That's what I've used in Ansible playbook. And as I start adding more microservices, all I'm going to care is be lazy and just add that FQDN here or domain name. And then this Jenkins will help me onboard that application so that I can protect this from OWASP or any of different web attacks. So let's go back here, refresh this. We see there is AWS GOAT that's added. And see that DNS changes update pending. But even before that, I want to show in my hosted zone of how Ansible have added that record already. So go to Route 53. And we see there is AWS GOAT, and this is the CNAME that's generated by FortiWeb. So you see it's actually is updated here. And now if we go back to FortiWeb Cloud and just update pending, oh, it's updated right now as I just click. So if we refresh on this page, we should see the DNS comes back okay. There it is. So the DNS is updated. So FortiWeb is going to start intercepting this traffic. Now, if we go into this application level, right, what we see here is the network is the origin servers are the endpoint servers or application servers. In this case, I have a Lambda and an API gateway in front of the Lambda. So those are my origin servers. Everything I've used in Ansible playbook. And the security rules, right? I turned on some security rules because that's what I thought I needed. But if you want to turn on more using your automation, using this automation approach, you can do them as well. And here, if we see, these are some categories, and these are turned on. So what this means is FortiWeb, FortiGuard Labs, like I mentioned, is our threat detection organization. We receive about like 5.4 billion threats, and the team uses machine learning and then create these signatures. So these signatures are continuously updated. So as a customer, you do not need to worry about updating these signatures, but they're just updated on a timely manner in the background. So all I have to do is turn on this radio button and do not care about anything else. So I have SQL injection, all of these different categories that are already turned on. And then we have other things like machine learning and a few other features as well, which we have demonstrated in the previous Cloud Field Day and Tech Field Day here. However, I'm just going to still talk about it in the next time. So Julian, do you want to actually try it again? And I want to stop sharing.
Real quick question. Do you have the ability, if, say, you don't have some of those options turned on and something starts happening in the system, do you have the ability to detect that and like automatically flip some of those settings on to help prevent? Or would it be more of a alerting and then someone come in and manually change things?
So two ways is we can actually generate emails if there is an attack and it has a certain threat level. You can automatically say send me an email to the admin. So as an admin, you can come fix those alerts. And then we have another feature called Web Vulnerability Scanner that's integrated, which will provide you some remediation because it's just a pen testing tool. In the FortiWeb. So it's nothing gonna fix automatically, but it's providing you the information of how you can fix and when to fix kind of features.
In addition to that, so what Srija mentioned, we have machine learning capabilities in there. So what we can do, for example, while you're developing an application or an API, it's evolving for itself. So and you're doing tests, you're doing integration tests. So we can say, okay, just learn on these integration tests because these are exactly the cases we would expect to have it. So we can teach it on that, and then if we bring it to the field, we have an onboarded machine learning data where we can say that's the usual what we would expect. Everything besides that, think about it or alert me and say, okay, that's not benign, that's not what I expect. So bringing a bit of that, so yeah, we can somehow evolve around what's not known, let's say that way so far.
Sure.
Exactly.
Got it.
Just want to show you, I did it again just some seconds ago, and what should I say? I got blocked, so I tried to again get the information from the etc passwd, but as it's an XHR request in the background, so you would not see it directly in your front that you put in some malicious traffic, but Srija should have it now in her logs, and you can see here Firefox was friendly for me and rendered that block page within the network editor of the developer tools. So yes, it immediately started blocking and preventing those attacks.
Share screen again.
Yes, let me stop here. Here we go.
So even before I show the attack logs, a few things I wanted to speak about FortiWeb Cloud and other features of what it can do is right now the demo I've shown is based on the signatures, right? The signatures are seeing this known attacks and the signatures were blocking this kind of SSRF attack here. So that's mostly all of our signatures help and protect OWASP top 10 threats that's there. And then bot mitigation. So previously for the Cloud Field Day, we used bot as for the juice shop, and Julian tried to use a bot to order all the juice from the juice shop. And it's very common, right? We have seen major shoe manufacturing company had that issue, or it comes to GPUs. The bots have ordered all of these shoes in a lot of more amounts, and then they try to sell them on third-party platforms, right, like eBay, for much more higher value or money. So we don't want to do that. So bot mitigation is something very, very common. So the FortiWeb also has like bot mitigation based on biometrics, threshold-based detection, and also machine learning-based bot detection. In machine learning, it's learning about your application, and it's just sees if it's a bot by evaluating in 13 different dimensions. So that's about the bot mitigation. And API security, what we've been seeing is a lot of companies, again, are using API approach. So as soon as they have an API, that's an additional attack vector that adds an additional surface. So usually what happens is they will have a JSON or an open API or XML SOAP kind of framework. There is a schema that's already developed by developers. So we can just upload that onto FortiWeb. So any request coming to your API is compared against that schema, and say if the schema matches, if there is a value called name, and name is a string, okay, so in the schema it's a string and it passes, then FortiWeb will allow it to your API. However, what if there are some shadow APIs which are not in the framework built by the developers? Then those are again exposed out, and you don't know they exist. And attackers like Julian, as always, can actually take hold of that or take advantage of it and then attack them, right? So we have machine learning based API learning as well. So what again is the same approach where any traffics that coming to the shadow APIs will be learned by FortiWeb Cloud, and it will actually build a swagger for us. So you see that there is this shadow APIs, and FortiWeb will actually start protecting them as it builds that swagger as well. So based on the amount of samples that comes. So all of these are the features. And it's a flexible deployment option. Last time we showed VM, virtual machine in public cloud. This is a SaaS offering for the same product. But if you would like to have it as on-premises or private cloud, that's also possible. Also as a container-based product as well. Now, machine learning is something which I also wanted to share because this is unique feature of, again, FortiWeb. So before I go in there and how to explain it easily, I want to ask you all, if you flip a coin, how many states does it have? Heads or tails? Two states, right? Thank you, Gina. So how about if I if I flip it 1,000 times? Still 2 is your answer?
Could be third. It could land on its edge.
Sorry, didn't want to. Yeah, 3 states.
Yeah, it could land on its edge.
Yeah, you just won the prize. Thank you. So 2 times is very common. Third time is 1,000 times we flip it. It might be a slight anomaly there, right? So any traffic that's going into your web application, it might be that heads or tails, but there might be this slight side landing anomaly that you don't want to flag your WAF as right away as a false positive, but you wanted to make sure it's a true anomaly. It's not benign. It's actually harmful. So with FortiWeb 2-layer machine learning, that's possible. So with application traffic coming in, it's passed through the anomaly detection. This is a layer which is built by learning about your application. All of your application samples, here heads and tails, are built there with a statistical model. Now when the landing on the side, that third state comes in, it's passed through this anomaly detection. FortiWeb have only seen heads or tails. Now it's seeing that side and it's sending it to the threat detection layer. This threat detection layer is again a FortiGuard threat models that are continuously updated in the backend. So now there is some vectorization that goes to that, and it's compared. That pattern is compared to the FortiGuard labs. And if it's benign, it's allowed. If it's a threat, it's blocked. So that's how it's helping. And how this helps is recently, if you are all aware, there was this Clarity's WAF bypass. where a team 82, it's an organization, I think looks like some threat detection organization. So they found some SQL injection based JSON syntaxes and have mentioned few of the major WAF vendors who couldn't block those payloads. So when we tested that with FortiWeb, it was not affected in first place. We are not on that list of affected vendors. But how machine learning helped is, since those were not in the known threats or signatures, and I have a app running from our previous time do shop, and as soon as I send that payloads, the machine learning knows that this is an anomaly, and it compared to the threat models, and it came as a SQL injection payload, and it blocked. I can show that attack as well on my FortiWeb cloud. But that's how it helps. And again, going back to the DevOps approach here, right? I mentioned about DevOps. I like CI/CD. And again, I'm not worried about, I don't want to keep tuning this WAF rules based on, because whenever I make changes to my application, I don't want to make sure I open a ticket to the network security team, the manager approves, and it's still a huge process for this changes to go through. So the machine learning helps in that way that it's just learning about the application, it's building that model. Nobody needs to tune any of these policies for the newly added parameters, and it's taking care and it's blocking that threats. So just as a final thing, machine learning, there is anomaly detection, which I've just spoke. But in this case, what we have shown in the demo is the attack signatures have actually helped Julian stop that attack when he tried it again. So going back, final thing is, if we reload this threads, we should see here. So this one is from today. So we see that there is on that save content, he have used this /etc password, and it correctly identifies the value as well. And it's just saying it's a block page. And that clarity WAF bypass, I have this juice shop, and we see these were done previously, but like we see, there is machine learning running and there is SQL injection. It identifies the SQL injection payload for those JSON WAF bypass, and it's showing us that attack logs as well. This is how it looks with the anomaly detection, machine learning.
So you got me again.
Yep.
Web applications are secure and automated, integrated.
Yep.
Network security is in there.
Mm-hmm.
I have one last thing I bet.
I think this
cannot prevent.
All right. So I think this should be our last if I'm going to win this one, or if not, I'm going to buy you something.
And I have to think what I have to buy you, right?
Yeah.
Maybe I have to pay for dinner today. So I don't hope so. So let me share my screen and show you my last idea I have. So my idea was, okay, I mean, it's all set up right, so we can do that within one cycle, bring it the WAF, bring the network segmentation. But one thing Srija can't do, I would say, is if someone messed up maybe some authorizations or stuff in the background. So talking about infrastructure as code, talking about permission concepts, I mean, talking about cloud native applications, they are mostly relay on authorizations and permissions within the cloud. So we're not talking about allowing communication for IP address X to Z. So no, we're talking about application X tries to communicate to another application. We give authorization and permissions for that. And that's sometimes quite complex and quite huge. And so I prepared something for that. And as I'm already again back on the attacker box, on my Vincent van Gogh box, because Srija was that friendly and allowed me access back in, I can use a script I prepared called escalation. I know I'm creative, which basically takes care of our IAM authorizations we have on our machine right now. If we have a look, that Vincent van Gogh box is a bit special because I have a caller identity. So I have an identity assigned. And so that instance itself has permissions to do something, which is not always the case, but can be the case. And you can do stuff with that. And also I'm lazy, so I also write scripts because I don't want to type all the time. So what I can do, or what that script basically at the end does, is it enumerates through which permissions policies are attached to my identity, which is assigned to my box, takes that and if you follow that full stream manually, you will notice there is one way that I be able to upload a new policy and attach that permission to another policy. And what I was able to do, I was able to attach it to the role block app lambda data. And if you remember previously, when I did that SSRF attack, I exactly impersonated to that account. So what I can do now is, as I have uploaded a full permission policy, I can switch exactly to that session, if it allows me to do that, like here. And if we check that again, there is SDS, get caller, identity. You can see here, I'm that block application data. And when I run my second script, so I just will add an administrative account. Just to be lazy, to be honest. But as I have the permissions now to add new users, I can grab for me that URL, go to my browser, and have that bad guy here with the, I hope I typed it correctly. Oh yes, I did, awesome. And yes, I'm in. And I'm not like an assumed user or something like that, no. I have full permissions. And now for free AWS access. So let me know if you want access to a new AWS tenant, just $50. So we can sell it. So Srija, I think now I got it, right?
So you can see all of my application that's deployed?
I would bet, yes. Look at that, 2 instances running. I always also deployed myself into your tenant.
So it seems like Julian have access to my AWS account where my actual application, this AWS code was running. All right, Julian, it seems like you won this time, but nope, not yet.
Why?
Just gonna show to our new product here. So gonna introduce to FortiDevSec. That's again our another product which is more on the application security side. So we all know, even before I jump into the demo here, I wanted to talk about what organizations have been actually going or using, right? Like trends, right? So previously it used to be waterfall management style, project management, where it used to be longer release cycles, slow, and everyone will work, all of the development teams would work in phases, one after the other. But now with Agile, what is happening is shorter life cycles. That means everything is in the fast pace. So security teams do not have that much time to check everything, right? No visibility into all of these modules because teams are all working simultaneously and in a parallel approach. So you need some tool which would help you with this kind of visibility, because we just saw Julian got access to my entire AWS account. Even though it's in the development, it's still an access to an whole AWS account tenant there. So let me run this FortiDevSec again. And FortiDevSec is our automated application security tool. It will do some comprehensive and intensive scans in order to find out any vulnerabilities in your application. So for this, there is AWS GOAT module. And all you have to do for this is, it seamlessly integrates into your DevOps Lifecyles, right? What we support here is, I'm showing Jenkins here, but if you have Travis or Circle CI, GitLab Actions, or anything, right, like a few others, or Azure DevOps, you can seamlessly integrate this FortiDevSec into your CI/CD lifecycle. And then it's just the Docker commands that we are running. So it's a Docker image that's going to be pulled on a runtime, and it will scan for some vulnerabilities there. That's what it's doing here. So I built a pipeline, and the FortiDevSec, when we onboard the application, so let me go to the onboarding page here. When you onboard an application, it generates you with a organization ID and a unique UUID. That's what you would need to use in order to connect your FortiDevSec scanning with your wherever this FortiDevSec YAML file is. So I have a root module where all of these files are exactly what I've used. My Terraform file, which I used to deploy this application, my Lambda code, all of that is in the root workspace here. So here it's in this module. I have all of these different files, and I also have a FortiDevSec.yaml file. In the FortiDevSec.yaml file, I have the UUID and the organization ID that FortiDevSec generated, so that it does know that this is the certain app that's being scanned when we run that pipeline. So let me run this one now. Do a build. Go to the trend. So it's there is some parallel scan is running. And meanwhile, if we look on the FortiDevSec here, go back to FortiDevSec, refresh. We see that there is the scan is in progress because that's the UUID and the organization ID. I'm tying that app with the FortiDevSec. So it's running. Once we see it's still in the scanning phase, but we can click here. What it has identified so far is there are, Julian mentioned that when he got access to my Lambda function, he was able to see a Node.js and a Python.py files or the code in my Lambda function. So it correctly identifies the languages here in your application. So if your repo or the source code has like anything like C++, C, Java or PHP or Python, it identifies those. And it already listed some vulnerabilities here. And we can see that some categories, if they're related to OWASP, then it just shows that as well. And if there are any secret files, that also you can see on the dashboard. And we can see actually, I'm not dumb here, so I'm a little smart. So I didn't expose my credentials here for you to access it immediately. But if there are something which I might have left in the development phase, you will be able to see here that there is a secret that's exposed and it's on this certain line in the code. So you can just go fix that one. So it's still, the scan is in progress because we see few of these things running here, right? And meanwhile, we see the job is success. So if I refresh this again, it should be good to go. So it's in review right now. If I click this one, we have few of these things. I'm gonna talk about FortiDast or shortly, but we see there's some infrastructure as code vulnerabilities here. So speaking of each of this, right? I have done a SAST scan. SAST is nothing but static application security testing, which is mostly like a white box testing. So what white box is that you have access to the code root module. My FortiDevSec had access to all of these files. And it's even before it gets deployed, it's seeing what vulnerabilities are in the code and giving you that information here. So SAST is against like some determined policies. It can do, it's comparing against those policies. And few other include like IAC, which is infrastructure as code. Like I mentioned, I use Terraform here to deploy my app. So infrastructure as code, what Julian has actually targeted is that he saw that there is no protection to my IAM roles, or even in the previous ones, we've seen that there is no protection to my, there are wide open policies to my S3 buckets in the first attack we have shown. So if you see FortiDevSec have actually identified all of those, and it gives me this comprehensive information, right? By actually giving there is IAM policy document here, and then there is some function, no public access block, so it's not blocking, there are public ACLs, and there are also some information about bucket. And if we click one of those, we actually see where that line is and which line it's, I have to go fix back in my Terraform file. And it also gives a description here. And with the code, if it matches any vulnerabilities, it also gives us that CVE number as well. And SCA is software composition analysis. And this is completely related to, like, say, if we are using third-party or open source projects, right? We have seen, again, a real-life scenario where Log4j was one thing previously. We used open source projects or open source code, and how vulnerable these were, because there is no one or no organization testing those for us, and we are not buying that service. So there is no one who is flagging that there is a vulnerability. So you need to have some visibility into this third-party tools. So SCA, which is again software composition analysis tool, is trying to do get some visibility into this manifest files or binary files or your code source files, and then gives us what vulnerability it finds. So developers can fix it in the early development stage here, or even if it's in production. And again, we see some Node.js. My app do not have a container because everything is in Lambda function and API. But say if you have something related to a container kind of image, it also gives us information about container vulnerabilities. That is also what FortiDevSec is doing. So overall, it's providing you some great visibility. So there is not much noise here. And even though it's just consolidating these attacks into one single line, right? Even though it's found in multiple places. And what we didn't show here is we also have Jira integration. So say you want to send an alert or generate a ticket or an email to your developers, we can also do that as well there. And finally, to the DAST scan. DAST is an dynamic application security testing where it's more like a closed box approach. What I mean is it doesn't have access to the source code files, but DAST becomes the tool itself. It will act as an attacker and it will start doing some attacks on your application. So it will see if there is any OWASP or any anything open to the internet, and it can find to see if there are any vulnerabilities, and it will generate a report for the developers to fix them when it's in production. So definitely will help Julian not gaining access to any of the AWS account once we have that visibility.
You went in and physically kicked this off. Is there a way to automatically kick this off when it's needed?
Yep. So one thing is for example, Jenkins have webhooks, right? Say you have this code in GitHub, and as soon as you do a Git commit, you can kick off your webhook, which would run this CI/CD pipeline. That's one way to do it. So any of the other integrations as well, any CI/CD pipelines, you can just create those webhooks, and as soon as someone commits the code or makes a pull request, this scan would kick off.
Well, in this case, you were doing it for an attacker. So like, can you scan it? Is there a way to hook it into some notification?
Yep. So once we run the scan, there is Jira integration here. So it can generate a Jira ticket once I initiate a scan or once it's complete.
Can you initiate it from a notification that something's not right?
Initiate once the notification is not right. Means like if you have different tools, or
yeah, I guess so. Like because you were defending against an attacker, so if an attacker got in, this wouldn't be the case of I'm pushing a change to production and this will get kicked off, which that's pretty reasonable and good too. But what if somebody does something like the attacker did? Is there a way to say, oh, you should go run this to make sure, or is it can you constantly have it running? Like, I don't know, like every morning, every night, like, is there a way to be able to kick it off if there's
like an attack
problem
generated?
Is there an automated approach when the attack happens to do this action item?
Yeah, so for this to go again to different approach, right? The SAST is more when it's not yet into production. It's when I'm developing the code. So that's where the attacks are not yet there, but I'm just seeing. But if it's a DAST, when somebody is attacking my tool or my app, we don't have that integration yet of like automatically kick off. But what I can see is as I make changes to my code and it's out in the internet, as soon as I make some commits or changes, then it will kick off that because it's integrated into CI/CD.
Okay.
So are you actually packaging something into the application to have this functionality, or is it something that's scanning the raw source code out of your repository?
Yeah, so it's actually, I just have this devsec.yaml file. That's the only thing I have, and in my source code at the root folder. So these are all my code files here. So just having this FortiDevSec.yaml file is something I need to have. And once I have it, what I used is this Docker images. So it's pulling this Docker, it's a private image, like it's public, but this repo is a private repo. So it's pulling that image and using this FortiDevSec.yaml file, which I have in the root folder, and doing a runtime scanning there while it's pulling that image there.
So think about, for example, SAST scanning. You better have the source code because you can see the imports of the modules and libraries to validate, are they maybe known malicious or what's happening there. That's for SAST. Yes, we take basically the files and go through it and check, or we all know, for example, for C or how to do a buffer overflow. It's pretty simple, well known what you could use and so on. But talking about Dust, so what we do is, so we spin up that application, then scanning it and trying to fuss input. So do input fuzzing, checking what's going on. Could we maybe exfiltrate files? For certain applications, for example, we know about certain vulnerabilities. I mean, Log4j is a pretty nice example, but for example, also for SAP or others. So we can scan through proxy also in the inside, but also on the outside to check, is that vulnerability existing there, or is there something maybe unknown so far? So it's both states somehow.
So I get that. I guess more the question was around bloat and whether it's like a sidecar type attachment for containerized application, or if there's going to be a persistent thing that exists inside the code.
It's just for that scan. So we spin out that container, it doing its stuff, and then it's gone.
Gone, yeah. Yep.
Where's the list of vulnerabilities coming from? Are you using CIS, NVD?
Yeah, so for example, for the SCA, we are using NVD, National Vulnerable Database, and for others we are using CWAE, that's the database, and we are also using additional ones our devs put together. So that's the database we're.
Got it. And is there a way to kind of create your own? Like, because a vulnerability could also be just a best practice that you want to kind of block, right? May not be something from a security perspective, but could be something that you want to block from a best practice perspective. Can I like go in and create my own that I would want to scan against, or?
Not on a particular vulnerability,
Okay.
not as such, but what we can do is there is a risk score that gets assigned to an app. So you can just scan until you want to reduce that risk score. Say you want it to be 5 and it shows 8. So you can just modify things so the risk score lowers. That's something, a kind of approach here. Yeah.
Oh, okay, got it. Makes sense. So if, I'm just throwing numbers out, one organization says, this is a 10, the other one says this is a 5, you can modify it to, yeah.
Yeah, you can specify that risk score.
Okay.
But, yeah.
Gotcha.
And each of this, for each of this to, like if I click on this vulnerabilities and we have the kind of status here, like if it's in a review or not, risk accepted, or if it's a false positive, you can select. So say if you identify one of it as a false positive or might not be relevant to your organization, you can select that status as well.
Got it. Thank you.
No.
Does it learn from those false positives? So over time, will it learn not to look for that, or will it look for it every time?
If you select one time, I'm pretty sure it shouldn't be seeing that false positive, because on that certain app, right? Because it has a unique ID. So if it's flagged as a false positive and you do that scan again, it shouldn't be showing up again. So going back here, just to summarize overall, a few things. The main attack today is based on the cloud misconfigurations, and that's more on the infrastructure as code. So the IAC module on the FortiDevSec, it's not actually fixing your cloud security, like going into your cloud resources and fixing those, but more about even before you deploy them, it's giving you information about what you need to fix in your Terraform code, or say if I have an Ansible or something else, like any config management tool, it will help you identify cloud misconfigurations there. And we spoke about software vulnerable exploits, which is the SCA tool that is in the FortiDevSec, and the vulnerabilities, SAST and DAST scans there. And finally, we're getting the test results, the security testing results, which we can see on the DevSec. So it's a automated tool, SaaS as an offering, providing visibility for all the developers. So it just is 3 steps. So I have this Docker pull registry that's on the runtime scan. It's just pulling that information that you can integrate into all of your CI/CD pipeline. So you don't need to do anything manually, no manual interruption, no disruption. Just add that .yaml file there, and then just use the SAST or DAST scan Docker pull images. Few lines of code there. And the second, so it's just in the this is the process or the architecture. Customer CI/CD, FortiDevSec agent is scanning the Docker images, for example, and using those Docker images, scanning it, and then uploading those results to FortiDevSec Cloud, the portal which we have seen. So you have some aggregated scan results there. So it's providing both like visibility, security access. You have logs, those vulnerability information, and you can have better management. Say if you want to assign some tickets based on if someone needs to fix that, you can integrate with Jira as well. So doing all of this different types of aggregator or multiple types of scanning on a single platform. Lastly, it's simplification and prioritization. Like I mentioned, we can prioritize based on the risk rating. So you can give a risk rating, prioritize that, fix issues, and so that the devs won't get overwhelmed. And again, it's on the development side as well. So even when the developers are releasing the code, they can just keep scanning so we can fix that code initially. So I think if I have actually went back and fix my S3 bucket or my IAM role, you wouldn't be able to do that again. But I wanted to be nice to Julian at this time and just want to give some credit to him, right?
Thanks. And yeah, for sure. I mean, afterwards, we all know what happened, right? But so having all of that like a full cycle, right? So we could have fixed, I would say, about an 80-90% before, and the rest of that could be done with other ways.
So I just want to summarize today. We have shown right from the development to how you can do protection to your instances running in cloud, serverless, and at the same time, use web application firewalls to protect your application security. And we have spoken about like shift left, shift right. It's a continuous cycle, right? From build, deploy, and run. So Fortinet have all the products there to protect against these attacks. And I hope you all enjoyed our demo.
It's obviously you can do source code scanning. Are there any limitations there in terms of language support? Obviously you'll have common ones, but what's kind of supported from a language perspective?
Yeah, right now we are supporting Python, JavaScript, C, C++, PHP. Even if you don't mention it in your SAS or in that file, it just identifies by default those languages. We are trying to improve more and keep adding more. Our developers are doing that. And also one other thing is, say you have a repo and your languages are just, you have other types of, right? Like say Terraform is your major, 90% of your code is Terraform and 10% is other different languages. It actually identifies it. So the limitation is that you need to have at least that Python code or C++ code, Java code to be 10% of the repo. If you don't, you can manually mention what kind of languages you have for it to scan. Otherwise, it should automatically detect.
And follow-up, I suppose, if it doesn't detect the language, let's say, will it still do a basic scan to, look for something like an AWS credential that's hard-coded in source code, or will it just fully ignore the file if it doesn't understand the language?
No, it does see if there is a username password in like shell is something in my demo, I didn't have shell, which it identified. But as soon as I added shell as a language and have a username password in my shell script, it just identifies it.
I noticed on the cloud native firewall, you could use FortiManager, and then there was a dedicated cloud native firewall interface. Do you guys have on the roadmap to integrate it with FortiCloud for management?
Good question, to be honest. I'm not aware at the moment right now, but let me come back to you with that later.